Part 2, Regions, Algebra Common Core, June 2015. For number 25, you are told to graph the function y is equal to the absolute value of x minus 3 on the set of axes below. Keep in mind it is x absolute value of x minus 3. And a lot of kids, for whatever reason, choose to ignore the absolute value sign. And I'm going to show you where you can find that on your calculator. You're going to choose the calculate icon on the home screen, and then you're going to hit the button to the right of the 9 button. And you'll get a screen that looks like this. Choose the absolute value symbol, which is in the middle on the left column, where you will see in the picture in a minute that is shaded in gray. So after you've graphed it, you can write down what the table of contents are by clicking Control T. I'm going to do it by hand, and I'm going to substitute in the values myself. So the absolute value of -2 minus 3 is 5. The absolute value of -1 minus 3 is 4. The absolute value of 0 minus 3 is 3. The absolute value of 1 minus 3 is 2. And the absolute value of 2 minus 3 is 1. So I'm going to plot these points. Okay, and you'll probably see on your calculator that these start to repeat. So we get a V. The absolute value graph is always a V. You use a straight edge in order to draw the lines. I'm going to have to freehand it, which I'm not too happy about, and I'll do the best that I can. But please use a straight edge and draw a very accurate line. Draw arrows on the end to indicate that it continues on infinitely. So now you're asked to explain how the graph of y is equal to the absolute value of x minus 3 has changed from the related graph of y is equal to the absolute value of x. So we talked about function shifting before, and as you can see, there's a function shift within the function. So that means there's a horizontal shift. And if you can recall, if it's a negative number, it's a horizontal shift to the right. So since it's a -3, there's a horizontal shift to the right 3 places. And if you go ahead and graph this on your calculator simultaneously with this graph, you will witness the shift because you'll get a graph that looks like this. And this is called the parent function. So when you start multiplying, adding, subtracting numbers to get some shifting, to get something to get more narrow or to get wider, it's always to the parent function. Alex is selling tickets to a school play. An adult ticket costs $6.50 and his student ticket costs $4. Alex sells X tickets, adult tickets that is, and 12 student tickets. Write a function f of x to represent how much money Alex collected from selling tickets. Okay, so an adult ticket costs $6.50, that's important, and a student ticket costs $4. I'll make adult tickets X and student tickets Y. Oh, he already told us to do that. So he sells X adult tickets and 12 student tickets. Write a function f of X to represent how much money Alex collected from selling tickets. Okay, so it's going to be 650X plus $4 times 12, or you could go ahead and multiply that and have 48. Both equations are applicable. They're both acceptable. So any of these two work. John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x is equal to 60 plus 5x. The total amount of money Sarah will save is given by the function g of x is equal to x squared plus 46. After how many weeks x will they have the same amount of money saved? Explain how you arrived at your answer. Well, the first thing I'm going to notice is I have two functions, two equations, and in order to determine when they are going to have the same amount of money is their point of intersection. So if you go ahead and graph this, you can look at the positive values of the point of intersection of this line and this quadratic, or we can just take those two equations and solve it algebraically and figure out the value. I'm going to do it algebraically because I can show you that visually on this iPad. But I'll also do it graphically and display the picture of it on here. Because of this little 2 here, it tells me I have a quadratic equation and all quadratic equations have to be equal to 0. That means I'm going to have to move these to the other side. And I'm going to combine like terms where I can and organize it so that I have the squared term plus a number times x plus the constant. So these two cancel out and here's my 0. I get a negative 14 here minus 5x. I need to switch these two so that I can use the x method in order to solve this. So factors of negative 14 that add up to a negative 5 are a negative 7 and a positive 2. I set each of these equal to 0. Solve each equation. And I get x is equal to 7. I'm going to reject the negative and accept the positive. So after 7 weeks, we have the same amount of money. And that's what they're asking us for. How many weeks? They're not asking us how much the money is that's going to be the same. Graphically, this is what it looks like on the calculator. However, when you go ahead and press enter to see the graph, you're not going to see anything there because the original constraints of your screen is like 6 point something. So I had to go ahead and change the window. And I started off with, since I already knew that I was going to be dealing with positive values, I changed my x min to 0. I expanded my x max to 100. Just to start someplace, and I changed my y min to 0 and my y max to also 100. And this is the picture that I got. So I could see that I had right up here in this area a point of intersection. And as you can see, it didn't go out too far for the x values. So I looked at the beginning values for x, and then I saw here's where they had simultaneous values for y. So it's after 7 weeks that they had saved the same amount of money of $95. Moving on. Number 28. If the difference of these two polynomials is multiplied by 1/2 x squared, what is the result written in standard form? Okay, so we've got two polynomials that we need to subtract. You always change the signs of what's being subtracted. So I'm going to start off rewriting this polynomial. I'm going to line up the like terms, but with changed signs. So negative x squared minus 3x plus 2. Very important step to remember. Change the signs of what's being subtracted. Okay, so 3x squared minus x squared gives us 2x squared. Negative 2x minus 3x is minus 5x. And 5 plus 2 is 7. And they're asking when that difference is multiplied by 1/2 x squared. Okay, so you must distribute, meaning multiply to everything inside the set of parentheses here. So 1/2 of 2 is 1, so I get x to the 4th power. You have to add the exponents when you multiply polynomials with the same bases. Minus 5 halves x cubed plus 7 halves x squared. Dylan invested $600 in a saving account at a 1.6% annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. Find to the nearest cent the balance in the account after 2 years. So this has to deal with exponential growth function, and we've talked about this on plenty of occasions. So this is the final amount is equal to the principal, 1 plus the rate raised to time. The rate always has to be in terms of a decimal without the percent, so I'm going to move the decimal over to the left 2 spots. So the rate is 0.016. Okay, 600 is the P, the principal amount. So since the interest was compounded annually for each year, T is equal to 2. $619.35. Determine the smallest integer that makes negative 3x plus 7 minus 5x less than 15 true. So we're going to solve this very similar to an equation using inverse operations as well as combining like terms. And I see that negative 3x minus 5x are like terms, so I'm going to get negative 8x plus 7 is less than 15. And I'm going to subtract 7 from both sides to get the like terms together. And divide out the 8. Now in doing so, because I have a negative number that I'm dividing by, there's something I must do that's very important to remember, and that's you're going to change the direction of the inequality sign. So since it's less than, it becomes greater than. So x is now equal to a negative 1. So the smallest integer that would make this true is 0. The residual plots from 2 different sets of bivariate data are graphed below. The key term is residual. Okay, so they represent how well the data is a good fit. Okay, when I evaluate graph A and graph B, we want to keep in mind that we're going to explain using the evidence from both graphs which graph would indicate the model for the data that's a good fit. And the one that's the best is graph A, because graph B has a pattern. And we all know that at this point in time, if there's a pattern with just the residuals, then the model is not a good fit. And we could see that it's spread pretty evenly above and below the x-axis here. So due to graph B being a pattern and the points in graph or plots in graph A are spread evenly above and below the x-axis, graph A is the model for the data to be a good fit. Moving on. Number 32. A landscape is creating a rectangular flower bed such that the width is half of the length. Keywords: rectangle. Width is half the length. The area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. So here's my rectangular bed. I know the area is 34. Area of a rectangle is equal to length times width, and the width is 1/2 the length. We just don't know what the length is. So length times 1/2 the length is equal to 34 if I think of this in terms of area. So 1/2 L squared is equal to 34. Now we have an equation we can solve. I'm going to get rid of the 2 and get L squared is equal to 68. I'm going to take the square root of both sides in order to get L by itself. And I'm going to look to simplify the square root of 68. So if I take 68 and I break it down to a perfect square times a prime number, I get 4 times 17. So 4 is a perfect square. I'm going to simplify that, in which case I get 2 radical 17 as my final answer. Oh, nope, not my final answer. Why? Because it says to the nearest tenth of a foot. That makes my life even easier. So all I have to do is take this value here, the square root of 68, and get the decimal equivalent. So that is 8.2 feet. This is our final answer. I have to follow instructions. So that concludes part 2 of this Regents. Move on to part 3.